So our last example here is going to be just a little bit different than the others. They're always a little bit different. Something that I want you to notice is that this rational expression can factor. So take a moment, if you're able, and factor the numerator. Here's a hint. Factor the denominator. Here's a hint. So if you want, go ahead and pause and see if you can make sure that you can factor this. The denominator is the difference of squares. The numerator, both values have to be negative, and the only factors of 2 are 2 and 1. Now, I'm going to actually put the 1 here. It does not matter, but you might already be seeing what's kind of special about this, which is we have a common factor. So if you're thinking, man, can we simplify this? We can. We can simplify to basically be able to say that the function that we started with is equal to x minus 1 over x plus 2. So that all we have to graph is x minus 1 over x plus 2, except x cannot be equal to 2. So notice that if we were to plug in 2 into our original, we would get 0 over 0. You can see that here as well before the simplification. What that means is these two functions are equivalent and their graphs are equivalent except at 2. And at 2, what we're going to have is something special. It's just a hole. It literally means that you're going to have an open circle at x being 2. Other than that, these two functions are identical. So we find everything in the same way. We have our y-intercept, which we just let x be 0. You can see if x is 0, now I'm only going to focus on our simplified version. We have a negative 1/2. For our x-intercepts, we've talked before about just letting the function be equal to 0, and the fact that a fraction can only be 0 if its numerator is 0, and that tells us that we do have one x-intercept at 1, 0. So we have our y-intercept 0, negative 1/2. We have the x-intercept at 1, 0. Now, let's come here and look at vertical asymptotes, and I'll kind of switch back and forth. But our vertical asymptotes, our denominator cannot be 0. Again, all I'm going to focus on is what my simplified version is. So we have a vertical asymptote at x equals negative 2. So if we want, we can go ahead and put that on our graph since we're over here now. Negative 2. We can put on our point, our y-intercept at 0, negative 1/2. We can put on our point 1, 0. That's our x-intercept. Now, like I said, the fact that 2 gives us a hole means it's not a vertical asymptote, it's a hole. It's a hole because the factor is in the numerator and denominator. That is why we have a hole. When you just have a factor that makes the denominator 0, only the denominator, you have a vertical asymptote. So that's what we have here. Horizontal asymptote, we can see that having x minus 1 over x plus 2, the whole idea there is that since this is now our function, as long as x is not 2, we can see that we have the same degree in the numerator and the denominator. So because of that, we can, the long version of this is, well, this is all we have to do. I'm starting to think calculus here. All we have to do is recognize that the degree of the numerator is the same as the degree of the denominator. So as x gets very, very big in the numerator, it gets the same amount of big in the denominator. And so because of that, the horizontal asymptote is just the ratio of the coefficients, which in this case is just 1 over 1, which is just 1. So we have a horizontal asymptote at y equals 1, so we can put that on here as well. So we have a lot of stuff so far. We're actually pretty close to being able to graph it. Coming back here, when we think about our signs, we'll think about our end behavior, so here. And then we have our x-intercept, our y-intercept. We can think about our vertical asymptote as well. So we have a -2, we have the 0, and we have 1. So 1, 0, 0, -1/2. We have our asymptote at -2. And then at 2, we have the whole. The whole. So there is no y value here. That's the whole point. There's going to be a whole. So we already know from looking at our asymptotes that y will be approaching 1 as we go to -infinity, positive infinity. That's our horizontal asymptote. And then we can just think about for our signs, remember we're just thinking about this function right here and what values we're getting, positive or negative on either side. So if we put in something like -10, you can see our numerator will be negative, our denominator will be negative, and a negative over a negative is a positive. If we pick something between -2 and 0, like -1, you can see our numerator will be negative, denominator will be positive. So negative over positive is negative. If we put in something like 1/2, so between 0 and 1, 1/2, negative, positive, so still negative. If we put in 1.5, positive, positive, it's positive. And after 2, anything like 10, positive, positive. So we have all our signs here. So that's enough to be able to do our graph. So we just want to remember that we cannot cross our x-axis at any other time because we've already decided. We also want to remember that we have to approach our asymptotes. So probably the biggest thing, because we don't have any points other than just our sign chart, we know that between -infinity to -2, we have positive values. So as opposed to being, don't draw this yet, as opposed to being down here, see, we can't be down here. Some of you may know why. Number one, it would give us negative y values, and our sign chart says they should be positive. Also, it would give us something that crosses the x-axis again, but we can't because we already found what the x-intercepts are, and they are not that. So we know that this is not going to be part of our graph. Because the values are positive, that's going to tell us that we want to get close to our, I'm doing the best I can here, close to our asymptote. So it's going to look something like this. You know, we are getting closer to the asymptote, so do the best you can there to get close. Notice those values are positive and they approach the asymptotes. On the other side, we do have to go through these 2 points. So we know it's going to look like this. We know that we're negative between those two. We also know we're negative to the left of x being 0, and we have to approach an asymptote. So we're going to come down here, like that. Then the key thing to see is that after 1, we have our sign chart is positive after 1. So we know we're going to be above. We also know we're going to approach our horizontal asymptote. So the only thing to remember is that we haven't done yet is that there's a hole at 2. And so you can now just kind of graph that hole and go past it. If you're thinking, well, what is that actual value? I mean, the y value is not there, but if you were to do f of 2 in our modified version, you can see that the numerator would be 1 and the denominator would be 4. So the actual hole occurs at the y value 1/4. So if that helps you, then go ahead and, mine's a little bit high, but that's where the hole occurs, is at 2 1/4. So let me just put that point, and I'll make the note that there is a hole. So otherwise, those 2 functions are exactly the same except for that hole at 2, and that is what this rational function looks like, this special rational function here. And that is the end of section 3.6.